Hello guys, welcome back. In today's video we are going to look into an important concept in Python called higher order functions. You often hear this term when working with functional programming. Don't worry, it's not as complicated as it sounds. I'll break it down step by step. At the end of this video, we understand what higher order functions are, how to use higher order functions in Python, and how you can create your own higher order functions. A higher order function takes another function as an argument, or it returns a function as its result. In simple terms, it's a function that works with other functions. Higher order functions are useful because they let you pass functions around like variables, making your code more modular. They also let you reuse code. Instead of repeating code, you can write one function and use it with different behaviors. Another thing with higher order function is it helps to simplify code by breaking down complex tasks into smaller parts. To really understand higher order functions, let's walk through how to create them from scratch. Let's first consider a function that takes another function as its argument. So let's start with a simple example. Imagine you have two different tasks or more different tasks. Maybe adding numbers, multiplying numbers, dividing numbers, raising number to powers. Instead of writing separate functions for each of them, we can write one higher order function that takes different function as an argument and applies it to the provided numbers. So let's say we have a function. Let's call it my calculator. So just like we said higher order functions receive other functions as its argument. So we are going to pass a function as a parameter here. Let's call the function, let's call it calculate. Okay, so let's use that as the parameter calculate, right? So the numbers that I want to apply this function onto, let's say we have A and let's say we have B. So we want to apply the calculate function on these two numbers. All right, so inside of our function, we are going to return calculate. Then we are going to pass these numbers as the argument of the calculate function. So we have A and we have B. Now let's define the functions that will be passing to this higher order function. So the first one, let's call it add. So we define another function. We have add function. Add function is looking for two numbers. You can also call it A and call it B, or we can say C or D. You can give it any name as the parameters. Okay, so for add, we're returning A plus B. Okay, that's what we want to return in add. For multiply, so we have another function that is multiply. This one is also looking for two numbers. We use A and B to represent those numbers. We are going to return, since it's multiply, we are going to have A multiplied by B. Okay, we can also have divide. We have divide. Okay, so we have two numbers that want to apply divide function on. So we can return A divided by B. Okay, we can also have another function. Let's call it raise to power. Raise to power. Okay, power goes with that. So we are going to raise A to the power of B. So what you are going to return from this function is going to be A raised to the power of B. You know that this double multiplications operator is used for raising a number to another number. That is our exponent operator. Okay, now we've defined our higher order functions and we've defined the basic functions that will be passing into our higher order function. So to see higher order function in operation now, we're going to call my calculator, which is the higher order function. My calculator is looking for 3 arguments. The first argument is going to be the function. So let's first perform the add operation. Then we want to perform it on, let's say, 6 and 8. Okay, so we can print this to see, or let's assign this to the variable of results. Okay, now we can print results. Let's run this and see what we have. So we have 14 as a result, which is the result of 6 plus 8. If we want to apply that on multiply, all we have to do is to just change this to multiply, which is the name of our function. We can say multiply. If we run that now, let's comment this out so we don't have 2 results in our console. So we have 48, which is the result of 6 times 8. We can also apply that to divide. Let's copy this. We have divide. 6 divided by 8 is going to give you 0.75. We can also test raised to the power. Now it's raised to power function. That's what we find that for. So 6 raised to the power of 8 is 1,679,616. So you can see the advantage of higher order functions. You only need to define your function once, and then you pass the operations that you want to perform as arguments to your higher order function. So you can apply different functions to the same higher order function, and it's going to apply the operation in the basic functions to the input. Another category of higher order function is a function that returns another function. This means that when you call the higher order function, the result is going to be a function you can use later. Let's say you want to create a function that generates a power function, that is, functions that raise numbers to a certain power. Instead of writing separate functions for raising number to a certain power, we can write a higher order function that generates these functions for us. Let's close our console for now. We can as well comment all this out. So a function that returns another function. Let's say we have a function, let's call it power function. Calling this power function. Is my function correct? No function. Okay. So power function is looking for a number, that is the number that is going to be the exponent. So let's represent that with power. So this is the higher order function that is going to return another function as its returned value. So we can define another inner function that is going to perform the actual operation we want to perform. So we can call this calculator, so just like we have in our previous example. So the calculate function will be looking for a number that will be raised to the power of the previous function that was generated. So the calculate function is going to return number, which is the argument that will be provided to it, to the power of the number that was provided to the power function. So we are going to have power. So now we are going to be having number raised to the power of power. Alright, so inside of the higher down function, we are going to return calculate. Returning calculate. Note that this return is inside of the power function, not inside of the calculate function. Now to see this in operation, let's say we want to perform a square operation, like number that is raising another number to the power of 2. So let's call this square. Square. We have a Q. I think I'm correct. We are going to have power function. Square is raised to the power of 2. So we are going to pass 2 to it. Now this square variable is going to be a function that will raise a number provided to it as its argument to the power of 2. So here we can now say we can find the square of, let's say, 9. The square of 9 is going to be 81. Square is okay. We have a here. Right, to see this in action, let's print our results, or we can as well assign this to results. We have results. Okay, now we are going to print results. If I run this now, let's clear our console. Actually, the result is 81, but let's clear our console, so we run that again and have a clear terminal. Okay, so you see now that the square function raise 9 to the power of 2, which gives us 81. So the power function, when we invoke the power function at this level, it returns another function. The function returned is assigned to the variable of square. And this is the definition of the function that was now assigned to square. And power is 2 during the invocation of the power function. So the result now is square, which is our calculate function here. Square is now accepting 9 as its own argument. We are going to have 9 raised to the power of power, which is 2. That is 9 raised to the power of 2, and then we have 81. So we can perform another example. Let's say we want to find cube. Cube is a number raised to the power of 3. So here we can say cube. Okay. So we are going to have power function, then raised to the power of 3. So now we can find the cube of, let's say, 2. The cube of 2 is going to be 8. So let's say our result is now equal to we have a cube. So let's pass 2. So now we want to find the cube of 2. The cube of 2 is going to be 8. Let's run that and see what we have. So 2 times 2 is 4. 4 times 2 is 8. One benefit of functions like this is that you can as well run this return function a number of times as you like, different inputs. So for example, as we have cube where you can also run it on another input. So let's call this result 2, and then let's run it on 3. So 3 times 3 is going to be 9, and 9 times 3 is going to be, I think, 27. So let's log result 2 into the console and see what we have. We can as well log results, so we have both our values in the console. So for the first line, which is the cube of 2, we have 8. The second line, the cube of 3 is 27. So you can run this a number of times as you like. So in this video, we've learned about what higher order functions are, how to create a function that takes another function as an argument, and how to create a function that returns another function. Higher order functions give you a lot of power to write flexible, clean, and reusable code. Once you get comfortable with them, we find many creative ways to apply them to your project. If you find this video helpful, don't forget to hit the subscribe button. As always, keep coding with Coding Atlas. I will see you in the next lesson.